in this episode.
Kant actually raised a very interesting question, a very good question. He noticed in particular that Euclidean geometry was not analytic in the sense of analytic he described, or in the sense of analytic we would describe now. And then he wondered, so you can't, it's not a matter of pure logic that space should be Euclidean. He was right about that. He was absolutely right. Now, other people realized that. I mean, this was about the time when non-Euclidean geometries were finally being articulated. And when Gauss realized this as well, that there are possibilities other than Euclidean geometry. Gauss's immediate reaction is, well, maybe the space we live in isn't Euclidean. Let's go check. Let's go send 3 guys with theodolites, surveyors, up on mountains far apart, and they can measure the interior angles of triangles, and then we see whether in fact they equal 2 right angles. They might or they might not. So Gauss's response was, as soon as you see that there are alternative possible geometries, it becomes an open question what the geometry of the space we live in is, right? That, I think, is exactly the right response. Kant's response was, no, I know a priori and with necessity that space is Euclidean. How could that be, right? That now becomes a piece of synthetic a priori knowledge. And man, if we did know that, that would be a good question, right? How could we possibly know of necessity that the space we live in is Euclidean if there are other completely coherent geometries that you could describe, right? Now, I think what happened to Kant was that he was just so convinced that it had to be that way that then he had to make up this weird theory that somehow the geometry of space is not outside of us and we're not finding out about it, but somehow we impose it, right? Our minds impose geometry on our experience. I mean, that's what he says.
Hey everyone, welcome to my conversation with the philosopher of physics and science, Professor Tim Maudlin, who in the last few decades has pioneered forwarding the field called the foundations of physics. This perhaps was one of the more philosophically oriented interviews Professor Maudlin has done, because normally he tends to stick to the technicalities of physics. But in this episode, we discuss everything to do with physics and epistemology, all the way from Kant's role in philosophy to what makes a good physical theory, and even what Wittgenstein and Moore philosophize on how we have certainty about our knowledge of the world. And speaking of epistemology and science, I felt it were a duty of mine to ask Professor Maudlin about Thomas Kuhn and Kuhn-Popper, the 2 giant philosophers of science of the 20th century, how their views differ, and Professor Maudlin's specific take on them. And no doubt, given I had this opportunity, I could not miss out on discussing the radical views of time of Carlo, Rovelli, and Smolin, and Professor Maudlin was kind enough to share his views on that too. Tim Maudlin has been chipping away at the foundations of physics for a long time. He's the author of numerous books, including New Foundations of Physical Geometry, Philosophy of Physics with Princeton University Press, and Quantum Non-Locality and Relativity. He's a founder of the, now I think, thanks to the internet, the well-known Joan Bell Institute for the Foundations of Physics, domiciled in Croatia. He taught for over 2 decades at Rutgers University before joining the Department of Philosophy at New York University. I have to say, I've been a student of Professor Maudlin from a distance for a long time. And so being able to interview him and ask him all of these philosophical questions was truly a privilege. And I have to say, he truly was a cordial person. And I really hope I can do another interview in the future, hopefully in person even. And of course, I should mention the fundraiser for the Joan Bell Institute is in the show notes. As the GoFundMe page states, the main aim of the Joan Bell Institute is to create a physical site dedicated to summer schools, workshops, and research in the foundations of physics. And now before the episode, a quick PSA. As you may know, I've mentioned multiple times that I'll never have advertisers or sponsors on this podcast. Frankly, I think we live in a society of excess and overconsumption, and I don't want to contribute to that by selling you another product or service that you probably don't need. That being said though, and forgive me for the tautology, we, for better or worse, live in the world we live in. I run this podcast on top of doing a full-time job. while doing research for my master's, and if I am to sustain this project, I need some financial backing. So if you have the means, please do consider supporting me on Patreon, Substack, or even PayPal. All the links will be in the show notes. And if you're wondering, what are the perks? What are you gonna get? The honest answer is nothing. That's right, there's no exclusive behind the paywall goodies. As far as I'm concerned, you're simply supporting this project if you think the already free content that's always going to be free is of any value to you. I sincerely do want to thank the existing supporters, and if you're considering supporting my work, please do so only if you have the means, especially in our precarious times. Alright, now to the episode. Professor Maudlin, I mean, let's start on a fun question. I'm curious, you're a kind of a publicly known figure in the foundations of physics, the philosophy of physics, but at the moment, what's really taking up most of your time in terms of both intellectually, what are you tackling and thinking about and kind of pulling your hair over, but also in terms of like your projects, stuff like the John Bell Institute, for instance, what's really taking up most of your time as a human being?
Yeah, I mean, well, I do teach, so a lot of time is just my regular day job at NYU. I was on sabbatical for the last semester, so I wasn't teaching, but then people ask you to do things you'd normally turn down, but you have the time. So I've been traveling like crazy. I mean, I went to Istanbul and taught for a week there, and I went to Dharamsala because there was a celebration of the Science for Monks and Nuns program, and uh, I had a
Wow.
workshop up in New York, and now I'm here teaching in Lugano. So I mean, a lot of time is just talking to people one way or another, talking to students or talking to people at conferences. In the spare time that I have, uh, yeah, there's trying to get the John Bell Institute really up and running, which has paid off I think very nicely in the last few months after years and years of trying to get it on a solid foundation. I think we finally have it on a solid foundation. Um, my own research, I've been working on a book for about a decade, and I hope sometime to get the time to finish it, the time and a little bit of help and expertise to finish it on space-time, on a possible way of thinking of space-time structure. Um, so that's kind of the big project that I have ongoing. But then there are all kinds of things. I mean, I'll probably write a book on statistical mechanics and thermodynamics to go with my other introductory level books.
Oh, that'd be
I have
great.
of miscellaneous essays on a lot of things that were never published that I would just write and stick in a file, and I'll probably try to get them put together in a book and published. So I've got a lot that I could be spending time on. Um, but at the moment, yeah, the within the last couple months, we agreed upon with the University of Split with a location, a beautiful location to put on summer schools. And then as soon as that was done, Angelo Bassi said he would like to put on a summer school this August. So this is really fast. So I've been involved in trying to get that. And actually, we're just about to put out the applications for that. So, you have to do this stuff quick because it's on very short time schedule.
Yeah, and these would primarily be on the foundations of physics,
Yeah, I
discussing
mean,
that, lectures
Angelo
on that.
wanted to do one on foundations of quantum theory for graduate students or early stage uh, PhDs, at that level, people who haven't kind of had a systematic introduction to the issues. So
Fantastic.
we pulled that together pretty quickly. I think it'll be a nice summer school.
Yeah. If I may ask, why in particular did you pick, if you're willing to share, Croatia as the to domicile the institute?
Well, it's a very straightforward answer, which goes through two steps. Step one, my wife is from Croatia.
Oh,
Um,
okay.
and on
Vishnu, Vishnu,
account of
yeah,
that,
yep.
for the last 20 years, every summer we spent time on the island of Hvar, which is just absolutely beautiful. It was because we were there that I met a physicist at the University of Split, and then we started putting on every summer a physics and philosophy conference at the University of Split. Um, But for various reasons, I actually wanted to try to establish a somewhat independent institute. But it's a beautiful location. I mean, the situation in foundations of physics is that the people who do it and the people who are interested in it are very scattered. They're scattered all over the globe. They're scattered in different departments. It's very hard if you're interested to be in a place where there are other people who are interested. So it makes a lot of sense to have work on this subject during the summer, where at least everybody in the northern hemisphere tends to be available, and then people can come and meet. And then you want to say, well, where are we going to come and meet? Well, the coast of Croatia is spectacularly beautiful. So if you're going to meet, you might as well come to a really, really, really nice place to do it. That was the basic idea.
Yeah. I remember one interview you did probably about a couple of months ago, and you were just like talking to the interviewer, and then you kind of did like a bit of like a pan of the camera, and you showed your background. You were somewhere in
Yeah.
Croatia. It was lovely, and I was like, this is the perfect place to be philosophizing physics
Yeah.
and ontology and all of these
Yeah,
questions.
that was the place had been trying to get, which is in a tiny little isolated village on the island of Far. That, for various reasons, became logistically impossible. But fortunately, at exactly the time it became impossible, the University of Split acquired rights to this beautiful location that actually once was Tito's summer residence and then had been turned into a thing called the Mediterranean Life Sciences Institute, but then that kind of went bankrupt. And so the University of Split now controls it, and we actually had an agreement with them, and then they gave us permission now to use it. So it's a great location for summer schools. I mean, well, we'll put on the first one in August and we'll see, but I think it has tremendous advantages. So I think that's going to work out beautifully.
Yeah, so do you think, apropos the foundations of physics, and I don't want to get too much into this because I know you've discussed this in many other podcasts, and I really don't want to have to make you repeat yourself, which is a waste of your time, and you probably get annoyed answering the same question over and over again. However, I'm curious in terms of like, let's call it to use this term, social epistemology or the zeitgeist of what's going on right now in the world of physics. Because of the work people like yourself, certainly, but even like David Albert have been doing by talking about the importance of, not having this shut up and calculate mindset, but rather asking the kind of the metaphysics within physics, like, like your book here, or like these ontological questions about the physical reality. So I guess I'll ask a question in this way. For a person like me, a non-physicist who has an engineering background, my attraction towards physics is really to what I would call the foundations of physics. Like when I think of physics, I always go to like refer to your work or someone who's working on that field. That's what I care about when I think of physics. But then, if I'm not mistaken, I've spoken to like certain physics students, so postgrads, undergrads, where they're looking on something very particular, and not to like sound insulting, but like they do kind of have a little bit of this shut up and calculate mindset without asking the big ontological questions. However, so my question would be, given that you've done this work talking about almost like, let's just call it like almost like activism, talking about the importance of asking the questions on the foundations of physics, that there's a shift in the zeitgeist where now, yes, you've got institutes like the John Bell Institute, but also like in the normal, typical university, there probably are even courses purely just on the philosophy of physics or the foundations of physics because they're seeing the importance of these kinds of questions.
Yeah, I mean, the funny thing is it's kind of a little backwards. The question should be, why in the world should you, should there have to be people in philosophy departments who are pushing,
Yeah,
trying to understand physics, right? I mean, this is what physicists ought to be doing. And what they did do, and what Newton did, and what Maxwell did, and what Boltzmann did, and what Einstein did,
Einstein, yeah,
is
yeah.
basically what we're doing. The real question is, how did they get away from that? How did this shut up and calculate idea take root? Because it's a deviation from the history of physics. It's a very extreme deviation, and if you talk to physics students and they give you that, I can pretty much guarantee it was beaten into them. I mean, they didn't go into physics. Nobody, young person says, "Oh, I want to be a physics major because I want to shut up and calculate," right? I mean, it doesn't make any sense, right? Um, Typically, you're interested in physics because it seems to be a way of finding out about the world. And the calculation is very much secondhand to that project. Um, Richard Feynman famously said, if only one sentence, if there was some nuclear catastrophe and only one sentence could be passed on, it should be matter is made of atoms. Now that doesn't allow you to calculate anything, right? But it gives you a fundamental picture of what physical reality is. Um, and from that basis, Feynman thought it would be much easier for people to rediscover all the stuff we had discovered, because once you figure out that matter has an atomic structure, then a bunch of questions take a certain form. Um, so physics was always really about that. And the calculational part, okay, there are people who are good at calculating, and if you want to do certain practical things, or if you really want to check what the predictions of the theory are, you do have to calculate. No one's saying, but nobody ever thought calculation, just calculating predictions was the point. Um, and I think sociologically, Bohr very explicitly argued, Niels Bohr, the so-called Copenhagen school, really tried to argue that physics had reached the end of a certain kind of comprehensibility. That if you were to seek really what you feel like understanding of what's going on, you're going to fail. And so the only way forward was just to use math and calculate some stuff. Now it turns out that Bohr was wrong. I mean, he was certainly wrong in the sense that we do have the poor few straggling people like Einstein who rejected all this and said, no, we really want to do what Newton was doing. We want to do what Boltzmann was doing. We want to do what Maxwell was doing. Um, the few of them soldiered on and did come up with perfectly understandable accounts of what's really going on physically, different ones. I mean, it's not that Bohr said you can't have any, but the actual fact is you can have several that are quite different from each other. And you can't decide experimentally between them. So we actually have kind of an embarrassment of riches, and you have to try and understand each one and see what their virtues and their defects are, and then ask whether maybe you could come up with an experiment that could tell between them. And all this should be going on in physics departments. It's a weird thing historically that it isn't. Now, because it isn't, a lot of physicists who are interested in these questions are very tempted to try to get jobs in philosophy departments because they can just pursue these questions in philosophy departments and nobody gets on their back about it. So, that's why David Albert, who has a degree in theoretical physics, teaches in a philosophy department.
Philosophy PhD.
What
Yeah,
do you
yeah,
want to do? Okay, it's that simple.
yeah.
So I would say, yeah, I mean, and I think philosophy departments, I mean, philosophy of physics is a little bit boutiquey, but I think departments think it
Yeah.
would be nice to have somebody around doing this stuff. I mean, it's interesting stuff. So,
Yeah, no doubt, no doubt. I feel like, especially, whenever I read any kind of philosophy to do with, speaking of physics, in the references, I see Tim Maudlin or David Albert. I see your name. I see the book, especially this book. Which one is this? The Philosophy of Physics one you did for Princeton University. And because I guess I'm thinking like, well, it is quite interesting. It seems like, again, maybe I'm misspeaking here, that there is actually more interesting work being done on the foundations of physics just on the internet, like people just connecting over like podcasts or different platforms and just publishing and putting it out there. And I wonder if that'll create a shift in the zeitgeist, and I hope it does, because you're right, like, I'm not a physicist, but if I were to go into physics, it would certainly be because I want to know what is
right.
the physical reality we are living in. Like, I don't care much about all the calculations. That's for me more means to an end.
Yeah, I mean, look, the internet has certainly had an impact here. I mean, all my life in academia, there have been meetings of people who do this work. They
Mm.
tended to be not huge meetings, and they were a little, you know, random times and in random places, but they occurred. Um, but if you weren't there, you weren't there. I mean, that's the reach of that was not great. Um, what the internet has done is provided access to the things we've been talking about for decades and decades and decades. I mean, David and I have been arguing with each other forever. Um, the internet just provides access to a lot of people who are interested in these subjects. And you just kind of can see from the number of hits or the amount of time people are willing to spend listening to some of these podcasts that there's a pretty strong interest just in the general public for
Yeah, I
discussions
mean,
comprehensible about what's going on. So I think that helps, right? I think even regular physicists might notice that, gee, why is it that the people doing physics podcasts that are getting a lot of attention are in philosophy departments, right? It might make them wonder what exactly is the story, and so I hope that'll be good. I mean, I must say it's a weird thing. I mean, recently did a podcast that's gotten over 125,000 views. In my entire life, teaching face-to-face classes and giving talks around, I would never talk to that many people over the course of my entire career, right? I
yeah,
couldn't.
I know what you mean. I mean, like, again, I'm not trying
You're in a
to.
different universe, right?
Yeah, yeah, yeah.
In terms of the impact you can have just because of accessibility. It's quite remarkable.
Totally. I mean, again, I'm not trying to like embarrass you here, but obviously for me, you are a teacher of mine. Like, I mean, obviously, I was telling you before we started recording, it's like it's a bit odd breaking the parasocial relationship because you've been in my ears for like months talking about relativity or whatever, and suddenly I'm like, wait, now I can interact with you. So it is a kind of a weird, almost phenomenological phenomena, apart from my own professors at my university. So and yeah, like I mean, for instance, the again the masterclass you did on Robinson's podcast. I mean, who would have thought that there'll be this much interest in someone talking about relativity for 4.5 to 5 hours? Like that's a long lecture. That's longer than a typical university lecture. And yeah, it's I think I totally concur. But on the note, Professor, I'm glad you mentioned Niels Bohr, because to bring us a bit towards the side of epistemology. Uh, of course, you and your peers, you guys have been quite critical of kind of Niels Bohr, his kind of, let's call it even ideology within the social epistemology of physics. And he is known to be this kind of neo-Kantian or like Kantian thinker who's been influenced a lot by the philosophy of Immanuel Kant. So
Mhm.
on the note, I'm curious, like, what are your views on the philosopher Immanuel Kant, since we are discussing epistemology? Do you think overall his influence has been inimical to philosophy and science, or just generally, what are your views on him?
Well, okay. So first of all, let me limit this to his metaphysics. I'm not an expert in moral theory or aesthetics, critique of judgment, the second two critiques. The first critique I know pretty well. I've taught it. I've studied it many times because I was very puzzled by it. I took a bunch of graduate classes by different people on it because I could never quite understand what he was up to. Um, and just to break the ice, I have said for many years that someday one book uh, I intended to write would have the title "Where It All Went Wrong: Immanuel Kant in the History of Philosophy."
Oh,
Um,
great.
so, I mean, I understand what Descartes and what Leibniz were up to on the rationalist side of things, and I understand what Locke and Hume were up to on the empiricist side of things. And there's always this picture that somehow Kant is where rationalism and empiricism meet, right? Like two great rivers meet, and he made this transcendental thing out of it. Um, but as far as I can figure out, having read this many times, what happened was Kant actually raised a very interesting question, a very good question. Um, he noticed in particular that Euclidean geometry was not analytic in the normal, in the sense of analytic he described, or in the sense of analytic we would describe now. Um, and then he wondered, so you can't, it's not a matter of pure logic that space should be Euclidean. He was right about that. He was absolutely right. Um, Now, other people realized that. I mean, this was about the time when non-Euclidean geometries were finally being articulated. And when Gauss realized this as well, that gee, there are possibilities other than Euclidean geometry. Gauss's immediate reaction is, well, maybe the space we live in isn't Euclidean. Let's go check. Let's go send 3 guys with theodolites, surveyors, up on mountains far apart, and they can measure the interior angles of triangles, and then we see whether in fact they equal 2 right angles. They might or they might not. So Gauss's response was, as soon as you see that there are alternative possible geometries, it becomes an open question what the geometry of the space we live in is, right? That, I think, is exactly the right response. Kant's response was, no, I know a priori and with necessity that space is Euclidean. How could that be, right? That now becomes a piece of synthetic a priori knowledge. And man, if we did know that, that would be a good question, right? How could we possibly know of necessity that the space we live in is Euclidean if there are other completely coherent geometries that you could describe, right? Now, I think what happened to Kant was that he was just so convinced that it had to be that way that then he had to make up this weird theory that somehow the geometry of space is not outside of us and we're not finding out about it, but somehow we impose it, right? Our minds impose geometry on our experience. I mean, that's what he says, right? Space is the form of outer intuition.
Yeah.
That suggests that if there are no creatures with intuition, then there is no space, right? It doesn't have any structure. I mean, it suggests that 13.7 billion years ago, when there were no conscious beings, space didn't exist.
Yeah, I mean, I
That's
can
kind of,
see
that's
where
kind of
like
crazy, you know?
idealism,
I mean,
I
I
can,
don't know what to
yeah.
say. That's kind of just lunacy. He kind of like Parmenides got convinced by a bad argument and just stuck to his guns. And he also had this very anal retentive kind of personality, as we know, right? He used to, you could set your watch by him taking his daily stroll around Königsberg or whatever, Frauenberg. Uh, and you just open the critique, and it's like everything, there has to be 12 of everything, and they have to come in four,
The categories and all that.
you
Yeah.
know and he's going to derive that there have to be 12 categories, and there can't be more and there can't be less. And poor Aristotle, all he did is list off a bunch of them, and he couldn't justify why exactly this many. And I mean, it's kind of lunacy, right? I mean, it's a really strange thing. Now, it's not crazier than, I mean, when I say it's lunacy, the way it's not crazier than, I don't know, Spinoza. I mean, there are other philosophers. It's just people don't take them so seriously. For some reason, I don't really understand. Um, no contemporary philosopher I know goes around bragging, I'm a Cartesian, or I hold a Cartesian view, like, substance dualism or something. But everybody wants to be Kantian. There's kind of a desire. I want to be Kantian. I think it praises a position that it is some Kantian aspect of some feature of the world doesn't really exist independently of us, but we project, it's a projection from our mind. I mean, that was supposed to be his Copernican revolution. And, I just don't get it. I mean, I'm not interested in stuff my mind projects. I want to get rid of the stuff my mind projects and figure out what's out there independently of my mind, right? I want my mind, insofar as possible, to conform itself to the world, not the world to conform itself to my mind. So I just and then of course after Kant, then you have Hegel and Fichte and Schelling and, I
The
mean, goodness.
idealists. Yeah.
Yeah. And idealism is, again, to me, it's like someone says, well, fundamentally what exists are just minds and their contents. I mean, that's what Leibniz believed, right? That's the monadology. And you say, what? Right? Again, 13.7 billion years ago, there were no minds and they had no contents, but there was a world, right? It was filled with very hot matter and photons and expanding space-time and all kinds of interesting stuff you wouldn't have imagined, and no minds. So it seems like you've just got things backwards if you think that the world is fundamentally minds and their contents, right? That everything we know about neuroscience says you can't have a mind without having a brain, and you can't have a brain without there being matter. And so, you got to have matter before you have minds. You can't have minds before you have matter. And we think we did have matter before there were minds. So I'm not really sympathetic to this line of thought, right?
Yeah, I mean, I have to admit, I probably am a bit more sympathetic, but I wouldn't say like rationally. It's more even like almost like a mystical bent to it. Like there's this notion I get a lot from like more like a kind of speculative philosophy that behind the phenomena there's nothing exists, and like Heidegger, nothingness, and all this. Like it sounds very mystical and alluring, but then that's where I'm always like I
Nothing,
go back
nothing,
to
and nothingness sure sounds mystical, but it also sounded
exactly.
to,
But
to
then
Carnap like gibberish. And I kind of
correct.
agree
So
with
it's like
Carnap there.
yeah, here's when I've got to say, like, I always sort of like pull myself back towards becoming a Maudlin, where I'm like, wait a minute, does this like common sense? Can I say, like, for example, when I go to sleep at night, that the world disappears, or like when I'm like now I'm in this room. There's a room outside. Like, does that mean the rest of my apartment doesn't exist? Like, there are some
Right.
things. You've made this point quite often. It's like, as any kind of an argument about reality or like physical reality, whatever the case may be, it has to be in a way explainable without like a common sense notions. Because if not, you kind of get lost in you almost like become like a level of a psychosis where So I can see that
Right.
point. So I mean, I
And look,
really yeah. Go ahead. Sorry, Professor.
yeah, I mean, look, if you think that somehow what we think of as physical reality depends on our observations or what's in our minds, you get the kind of observations that Hume made, right? You have a fire burning in the fireplace and you leave, so there's nobody in the room watching it, and you come back a few hours later and it's burnt down to ashes, and you say, well, that's because it kept burning when nobody was watching it. Now, of course, you can always, Deus ex machina, um, wheel in God, like Berkeley does. Well, God was watching it all the time. But, I mean, reaching for God, that's a sign of desperation. Right? I
I
mean, it really
agree.
is.
Yeah, I agree. Yeah. Yeah, I mean, I'm curious. So again, I mean, you're not like a sociologist of science or anything, but just it's really interesting on this podcast, but also just like listening to other podcasts. When I speak to philosophers, you don't really find when it comes to Kant or German idealism, you don't find like a middle ground.
Mhm.
Either people think it's just utter nonsense and like it's in fact where everything went wrong, or as you say, people are like, I'm a Kantian. This is like completely like it's in fact almost like an identity to a certain extent, but why do you think, like as you say, yeah, like I don't hear people saying I'm a Cartesian or I'm a Spinozian as like such an adamant way with such zealousy, so to speak.
Right.
So why do you think Kant created this major split both in philosophy and science? I mean, a part of me, I would say, I would probably give like a psychological argument for that, saying that there's something really peculiar about human beings where we do have this almost mystical religious bent to us. And I think Wittgenstein made this point that here's where metaphysics and religion touch, where there's like we have this need to believe in this kind of like almost, to use a bit of an insulting term, woo-woo-ness of reality. But I'm just curious, have you thought about why there's this major split when it comes
Well,
to Kantian philosophy?
so I mean, there's the following, you might say, grain of truth in
Mm.
some of what Kant says when you say there are certain things we take to be features, mind independent features of reality that aren't. They really are projections from our consciousness out onto the world. I mean, the standard examples were perceived colors, right? I mean, and it does take you a bit to understand that. I mean, my son is colorblind. I know for sure when he looks at things that his color experiences are not like mine. Um, and your immediate reaction is, oh, the poor guy, he can't see what color it really is. And then you have to stop and think, wait a minute, what makes me the expert here? Right? Why is it that I'm not seeing it right and he's seeing it right? And then you think another little bit, and then you see, well, nobody's seeing it right or wrong. And this, takes you already back to Democritus, right? By convention, color, by convention, flavor, and so on. In reality, atoms in the void. So, I mean, it's certainly true that sometimes there are mind-dependent structures that are mistakenly believed to exist in the world independently of the mind. But once you realize that, Democritus's idea was good. Let me figure out which those are and then kind of ignore them and figure out which ones aren't dependent on my mind, like shape and motion and so on. I mean, this was how you got the primary, secondary quality distinction in the empiricists in Locke and Hume and so on. Perfectly reasonable thing to do. This idea then that we're projecting structure out rather than finding it in the world just goes crazy with Kant, and he extends it to space and time and causation and kind of everything, and that's just way too far. I mean, I like to say that there's a funny quote. Thomas Kuhn says he's a Kantian with variable categories, and you're going like, if there are variable categories, this is not Kant. I mean, Kant's whole point was that the categories are not variable. And what Kuhn meant again was, oh, the way we think about the world depends on our conceptual system. Sure, it does. Of course, it does, right? To some extent, and you should kind of try and be careful and think about where it does and how much you can trust that you've gotten something objective. I mean, those are good questions. But Kant just had this idea because he wanted to preserve the idea of a priori synthetic knowledge and necessary knowledge of necessary truths. That's what was motivating him, that he had to take that projective part and make it completely ironclad and inescapable. And the amazing thing about the human mind is it's very plastic, right? I mean, the human mind is capable of changing its conceptual systems in quite radical ways. To really understand general relativity, you've got to absorb a bunch of unfamiliar concepts and start thinking in different ways, and you can. I mean, we're really good at that. And Kant kind of wanted to lock us into a single conceptual system we couldn't escape. And that's just bad psychology. Right.
Yes. All right. I'm glad you mentioned Kuhn. I mean, I was going to ask a bit about, because I want to discuss this piece he wrote on common sense. I think he called it quantum theory and common sense. It's complicated. But since you mentioned Kuhn, I'm curious. So I haven't really heard you discuss Thomas Kuhn much and his whole notion of paradigm shifts and stuff. And I was recently just writing an essay on Kuhn for my master's degree, and he has this infamous chapter X where he says, when the paradigm shifts, it's as if reality itself shifts. So here's very content. I probably can't imagine what I probably know what you're going to say about this, but just in general, I mean, the two big philosophers of science that I discussed, they're almost like, I'd say Thomas Kuhn is almost like a bit of a mini celebrity in philosophy of science. What are your views on Thomas Kuhn, his notion of paradigm shifts, and then the other big one, if I may also just add as like an addendum to that question, would be Kuhn-Popper and falsification. These two big figures. Just generally, Professor, what are your views on them?
So, look, Kuhn is a mixed bag. And as you say, there's the X-rated chapter X in Destructive Scientific Revolutions. And pretty much 1 through 8, I like those. I mean, Kuhn brought serious historical understanding of science to the discussion of science. And at the time that happened, that was new, and you had a lot of kind of cartoony science. People really hadn't studied the history, they didn't understand it. They had very cartoony views of it. And the serious historical study of science was a really, really good thing. And Kuhn gets a lot of credit for that. Um, the stuff about you have to be careful. He defines incommensurability between paradigms. He actually does define it, and paradigms are supposed to be incommensurable if the things postulated in one cannot be defined in the vocabulary of the other. That's essentially
Of the
the
other,
idea.
yeah.
Yeah, and okay, you can say that. The problem is what people think is that incommensurability in that sense means incomparability, that if they're incommensurable, you can't say one is better than the other, or one is better supported by the evidence than the other, or one is more credible than the other. That's just completely false, right? So in Kuhn's sense, I mean, Aristotle had a theory of matter, right? There's earth, air, fire, water, and ether. That's what there is. That's incommensurable in Kuhn's sense with modern chemistry. Because if you ask, but in terms of modern chemistry, what is Aristotelian ether? The answer is you can't define it in terms of modern chemistry, right? Um, but if you were to say, but doesn't that mean we can't say that one is better than the other? You say, of course we can, right? I mean, Aristotle was wrong, right? I mean, Aristotle thought the moon was made out of something very different than the earth. And, we've been there, we brought rocks back, and it's not. I mean, there's this slide between incommensurability, as Kuhn defines it, and incomparability. And people think incommensurability means incomparability, that you can't rationally say one is better supported by the evidence than the other. And that's just nonsense. Unfortunately, Kuhn himself says things like that sometimes. And, you have to remember, I don't know if you know the history here. Originally, Structure of Scientific Revolutions was supposed to be part of the Encyclopedia of Unified Science, which was a
I didn't
bunch
know
of
that.
little books, right? A whole bunch of little books. And so it was very limited in how long it could be. And they actually wanted somebody else to write it. I can't remember who. And the other person said no, but there's this young kid, Kuhn, ask him to do it. So they contracted Kuhn to write this thing, and he did. But he always thought of that as a first draft of what should have been a much longer and more careful discussion. And he kind of, for the rest of his life, tried to produce that and never did. And I think the reason he never did is he couldn't even make sense out of what he said. I mean, he just couldn't get this idea of incomparable, this kind of weird idea that science is not getting closer to the actual way the world is. And so he couldn't really make sense of it in the end. And I think that's why he never really published the big book that he thought he would publish. Um, but I don't want to take that much away from, I don't want to take away, he did serious historical work. His book on black body radiation is nice. I think the Copernican Revolution book is very nice. And I think the first 8 chapters of the Structure of Scientific Revolutions is very nice. I just think it goes astray at the end. Now, as for Popper, I guess I would say Popper, again, if you read him carefully, he's more subtle. There's a cartoon Popper that people often appeal to, um, about falsifiability as if it's this absolute thing. If you read the logic of scientific discovery carefully, he's pretty careful, and he puts in the right caveats. I would say I like Lakatos better. Lakatos was Popper's student, and he thought he was producing a better, more refined, more defensible version of Popperianism, and I think he did. Um, so I myself think that the insights you can get out of Popper, such as they are better accessed through Lakatos. That's just my opinion there. Um, Popper's in a way easier to teach to undergraduates.
Was Lakatosh? I
Although,
haven't read much of Lakatos at all? Like, is he the one with the research programs notion and all of that?
Yeah,
Like invented the concept?
yeah.
Yeah, correct.
Research
Yeah.
programs. I mean,
I mean,
the
we.
methodology of scientific research programs. I mean, the book based on his thesis, Proofs and Refutations, is about the methodology of informal mathematics. It's just wonderful. It's written as a dialogue of this teacher and their students, and it's lively and funny and really deep, really deep. I mean, I think
Mm.
Lakatos is terrific. He unfortunately died in a car accident rather young. Um,
Okay, yeah. Yeah, I mean obviously the I guess the big prize in the philosophy of science is given it's after the Lakatos Award or the Lakatos Prize, right? So it's like
Mhm.
I really should read more of him. I know of him because of just like the other Popper and the rest of the philosophers of science. But I think if you're saying he's worth reading more than even Popper, I'll definitely give him my
Look, I
time.
mean, again, Proofs and Refutations is a funny book because it's not about empirical science, it's about math, but it is just a
Mathematics.
delight. It is a
Mm.
delightful book to read. I mean, if you just read it for fun. And it's deep. I mean, it's just lovely. Um,
Yeah, yeah. So, all right, Professor, when you were talking about this whole notion of incommensurability and kind of paradigms and whatnot, one from this is the book, Quantum Non-Locality and Relativity. And then in the first chapter itself, in this, where you were outlining Bell's theorem, so you kind of, you say, okay, what is weird about the quantum connection? And then you outline well, you enumerate 3 points. The quantum connection is unattenuated. The quantum connection is discriminating, and then the third one you say the quantum connection is faster than light, instantaneous. So the
mhm.
entanglement bit, and then afterwards you keep going, and then the latter part. I'm just going to read out this bit just for the listener. You say. Our concern will almost be with the last of these three features. So the instantaneous spin, and you say it is surprising that the communication between particles is unattenuated and discriminating, but often our best counsel is simply to accept the surprising things our theories tell us. Then you keep going. The speed of the communication is another matter. We cannot simply accept the pronouncements of our best theories, no matter how strange if those pronouncements contradict each other. The two foundation stones of modern physics, relativity and quantum theory, appear to be telling quite different things about the world. To understand and perhaps resolve that conflict, we must consider carefully just what relativity tells us about space and time. So the reason I read that bit out was, you know, if let's call it like a quasi Kuhnian or like a caricature of Kuhn would say, oh, does this mean quantum theory is a paradigm shift in science, and suddenly we have to move from relativity to kind of the world of quantum mechanics. So to that kind of argument, and I know I don't think Kuhn would say this
Mhm.
either, but so just yeah, I know there was a lot here, but like if you could just outline this incommensurability, but also why we should not view something like quantum mechanics as like a paradigm shift and gives us like a new reality or whatever, as bizarre as that sounds.
Well, I mean, in Kuhn's terms, of course, quantum theory is a paradigm shift. I mean, no one would dispute that. But
Mm.
a paradigm shift from what? From Newtonian mechanics, from
Okay,
Boltzmann,
okay,
and
yeah, true.
and from Maxwell. That is, quantum mechanics is in the first place essentially a theory of matter. It is not a theory of space and time. It tends to just take some given space-time structure as given. And in terms of that space-time structure, and so that's why you've quantum mechanics that you first learn is set in classical space-time, in the space-time of Newton, essentially. Um, and then there's a question, well, can we do this in relativistic space-time? But so the subject matter is what is the nature of matter and how does matter work? Quantum mechanics is certainly a paradigm shift from Newton, from classical mechanics, and from classical electromagnetic theory, Maxwell, for sure. Nobody's going to dispute that. Um, and the reason we take it seriously is that it just makes that classical physics, classical theory of matter ran into some problems it couldn't solve, like the stability of matter. It just couldn't, if you take essentially Maxwellian electrodynamic theory and try and understand atoms, you're going to say that electrons are going to spiral down into the nucleus and, the whole thing's going to fall apart. So there was a question. And quantum mechanics certainly makes better predictions in that regard, right? It
Correct.
doesn't predict that matter will destroy itself. So that we have every reason to think that in some way, quantum mechanics is closer to the correct theory than Newton's theory, and that is a paradigm shift. But it wasn't about space and time. What I'm pointing out in that statement, and I actually forgot I wrote that, but I'm giving talks literally now called the I don't know, the Great Tension, which I'm making exactly the same point 40 years later. The point I'm making there is that it's a very different thing to say that quantum mechanics, which we have very, very, very good reason to take seriously, and relativity, which we also, in some sense, have very, very good reason to take seriously, contradict each other, right? You
Yeah.
can't take them both seriously. I mean, that's not a matter of incommensurability. That's a matter of logical incompatibility, right? They just, I mean, if one
It's
says
an
nothing goes faster than light and the other says something goes faster than light,
yeah.
I can't wrap my head around that and say, well, I'll just accept both of them, right? Something's got to
That'd be
give.
absurd. Yeah, that'd be absurd. Yeah.
And my view is that what has to give is relativity, that the relativistic account of space-time structure isn't right. That's actually this big book I've been working on, and other people, if you say relativity isn't right, then of course you're obligated to say, well, what do you replace it with? I mean, and that takes work, and there are different possibilities, and you have to try and think them through, and you have to try to articulate them and actually do some theorizing in terms of them and so on. It's hard work. But this isn't incommensurability. This is logical incompatibility. That's a problem that no paradigm shift can make go away, right?
Yeah. Yeah, that makes sense. I mean, so I guess the argument you're trying to develop is we need to pick one side, so to speak, in the
Yeah,
sense that we
and
gotta
furthermore, I think
chase in
we know
relativity.
which side it has to be, because
And
the thing that indicates that there's superluminal causation is violations of Bell's inequality.
inequality.
And you
Yeah.
just see that in the lab. You just go into the lab, you do some experiments, you collect some data, and you say, hey, this data violates Bell's inequality, right? And as soon as you have that, you say, well, no local theory can give me that. No
Yeah.
causal local theory can make that prediction. So causal locality is out the window. And that means something does, as it were, at least there are causal connections that are superluminal. And if relativity is understood in a way as saying, which is the way Einstein understood it, that there can't be superluminal causal connections, then I'm sorry, you have to get rid of relativity. Then you should think, what should I replace it with? I think that's the
Mm.
situation. I don't think it's like just, oh, I have two conflicting things. Which one do I give up? We have two conflicting things, and the experiments tell me which one to give up.
Yeah, we stick to empiricism. Yep, that makes sense. I mean, also like this is you've spoken about this in many places, so again, apologies if you've got to repeat yourself, but like the whole spooky action at a distance, right? Einstein, that's what really turned
Yeah.
off Einstein about this thing. Yep, excellent, excellent. Well,
Yeah, that
thank you
is
for
an
clarifying that.
intrinsic
Yeah.
feature to quantum theory. Einstein hated it. He hated it from the beginning. He hated it in 1925 when the new quantum theory was developed. And he hated it ever since. And he wrote the Einstein-Podolsky-Rosen paper in 1935 because he still hated it. And he rejected De Broglie's and Bohm's theory because he hated it. That's what he hated about quantum theory. And what Bell showed is, sorry, can't get rid of it. You can't get rid of it and keep the same predictions, and the predictions are correct.
Yeah, just on that, I would say to the listener, read Professor Maudlin's the philosophy of physics book, the second one on quantum theory. I forget where, but you do outline this whole the Einstein, Podolsky, and Rosen paper, and the whole story is there. So just read
Yeah.
chapter one, the 8 experiments chapter. It's well worth your time. Excellent, Professor. All right, so now again a bit back to epistemology. The other two thinkers I want to discuss, because again, I told you, right? So you've said in many places, and that's why I always, whenever I think of like physics or the foundations of physics, I almost like verify with what you're saying whenever someone makes a statement. And that's because you've said that any any reasonable theory of physics or ontology of physics, it has to be in a certain way explainable through our common sense understanding of the world. So, two philosophers I can think of that have really defended this, what you would call ordinary language philosophy or like common sense, is in the 20th century, is Wittgenstein and G.E. Moore. Now, obviously, in very different ways, they approach this. I mean, I think Wittgenstein had a very almost like a mystical bent to him, certainly. But I'm curious, let's just say, apropos philosophy of physics and like kind of the way you argue about physicalist ontology. What are your views on those two thinkers, Moore and Wittgenstein, and just generally, have you done much thinking into the way they, like Wittgenstein has it like language games and all these things? Just what are your general
Yeah.
views on that?
Okay, so I think you're misinterpreting when I talk about common sense. I'm not doing anything connected with either what Wittgenstein or Moore were doing. Um, in fact, I mean, so for 50 years, physicists have been pursuing something called string theory, right? I'm sure you've heard of it.
Of
And
course.
that is certainly the ontology being proposed there, insofar as you can make any clear sense of it. One thing for sure is it's not common sense, right? I mean, it's
Yeah,
space-time
yeah,
has 10 dimensions and they're
yeah.
compactified and blah blah blah.
Multiverse
Okay.
theory, it's
Now,
it's
I don't have
mind
a
blowing.
problem with this. I don't have a problem with string theory for that reason. I don't think that, I mean, the ontology of quantum theory is not common sense. So I don't think the ontology of a theory is what it fundamentally postulates as existing. And I don't think that has to be stuff that is already familiar to us from common sense. The point I'm making is that the evidence, I mean, these are empirical theories, right? Which means the reason we take them seriously, the only reason we have to take any of them seriously, is that in some sense we make observations that they can account for, or that provide tests of these theories, and they pass these tests. And the observations have to be described in a more or less commonsensical way, what Wilfred Sellars called the manifest image of the world, right? Like language like um, more dots appeared on this screen to the right than to the left of this line. Okay. I mean, that's like language everybody understands. That's the language in which the data is ultimately given. And since the data is given in that way, somehow your theoretical postulates, however weird they are, have to connect up to that language in a comprehensible way, right? You have to be able to see, oh, yeah, maybe the world is made of strings, but what do the strings have to be doing in order for dots to appear on a screen, right? If you can't answer that question, then you can't connect the data with the theory. So I think that's just a methodological requirement. Now, let me just say a couple words. Look, more as I understand it, I mean, I know a bit about, I certainly know that the hands argument, he was worried about certain radical skeptical claims about
External
knowledge.
world, yeah.
Um, um, as far as I'm concerned, skepticism is an interesting, I know actually a fair amount about the history of skepticism. Um, it's a great philosophical topic, but radical skepticism just shouldn't get into the discussion of physics, because if someone, I said, look, we did an experiment and it shows that there's this non-locality in the world, and somebody could come along and say, wait a minute, what if I'm like in the Matrix? What if I'm been kidnapped by aliens and I'm in a pod and they've stuck a thing in my spinal cord, and they're feeding me all of this completely made up story about experiments being done? Then couldn't the world still be local? And you say, yeah, of course. But look, that's not the kind of doubt that you should be doing in a physics lab, right? I mean, you have to take certain experiments seriously and their outcomes seriously to do physics at all. So, sure, you want to talk about radical skepticism, that's fine. Do that in a philosophy department. But that part of epistemology shouldn't leak over into your account of science, because it's kind of on a different scale. You kind of have to put those kinds of doubts aside as not relevant. Um, I think Moore's hands argument was, of course, kind of interesting. they were dealing with some interesting epistemological questions. So was Lewis Carroll's Achilles and the Tortoise was dealing with some interesting epistemological questions, right? There have to be certain claims that you regard as self-evident in the sense of the Greeks, but you have to understand also, I think it's a subtle thing, that self-evidence doesn't mean you're sure they're correct. It means that they automatically have credibility, high level of credibility, but you might be able to overwhelm even that by other things. I mean, this is the kind of Neurath ship image of you have to rebuild the boat from the inside. I mean, so I think I understand what Moore was doing, and I'm kind of sympathetic to certain points he was making. Wittgenstein, now that's a whole other kettle of fish, as you know. And then there's there's the Wittgenstein of the Tractatus, and then there's
Tractatus, yeah.
Wittgenstein of the philosophical investigations. I'm not very sympathetic to the philosophical investigations. I mean, I think the reason he wrote the way he wrote there is that he couldn't. I mean, somehow in the Tractatus, he thought he had really sharp arguments and he could sharpen them and 1.1, 1.111, 1.1. I'm going to get clearer and clearer and clearer about what I mean. And in the philosophical investigations, they're investigations because he's kind of fumbling around, and he says something, and then a few pages later he contradicts it, or he says, no, that argument wasn't any good, and you nod your head and you say, yeah, that argument really wasn't very good, but what are you going to replace it with? Wittgenstein seemed to have had some magnetic personal effect on people that made them think he was a genius, and I'm pretty suspicious. So did Bohr, by the way. People somehow, I mean, there are people who say, gosh, speaking to Bohr, I felt like I was talking to Jesus or Buddha or something. You go, my God, what must that have been like? But I'm pretty suspicious of that reaction. I mean, I talked to John Bell several times, and nobody do I admire more highly than John Bell. But I don't think I was talking to Buddha or Jesus. I was talking to a really smart guy who was really clear and a really clear thinker, and who could, make really sharp arguments and make really clear distinctions and point out very important, places where something happens in an argument, which did not strike me as supernatural. He was just really smart. So when people say this kind of almost semi-mystical talk, this rubs me the wrong way. I mean, that's just the way I am. It doesn't attract me. It's just the opposite.
I concur. I mean, also with Wittgenstein, it's funny what you say about his the philosophical investigations. I've spoken to Wittgenstein scholars on this podcast. They themselves say that was his worst book. I mean, not worse, but they say that's just a bad book. Firstly, he didn't publish it, but also it was simply his notes. It was kind of like his book Uncertainty, which is the one that I've studied most carefully. So it's in the 20th century. There are these two figures, Wittgenstein and Heidegger. It seems people are obsessed with them in almost like a religious, quasi-mystical way. And I wonder why.
Let me go back for 1 second.
Yeah, please go
this
ahead.
is because of Kant, because Kant is a terrible writer.
Oh yeah.
Kant is a dreadful writer. You can't follow his art. I mean, I spent so much time tracing down the main argument in the first critique. Here's the premise. Now, a few pages later, here's the conclusion. How the hell did he get there? And you're chipping away bit by bit, forward and backward, until you get it down to one paragraph, and then you notice there's a modal fallacy in the middle of that paragraph. You say, oh, that's where the mistake is. But he's a terrible writer. I mean, and Hume is such a beautiful writer, right? And Leibniz, by the way, is a beautiful writer, and Locke is a beautiful writer. They're clear. You know what they're saying, right? You understand what they're asserting. Maybe you agree with it, maybe you disagree with it, but you know what they're saying. It's very hard to understand how Kant thinks he's arguing. And I think the fact that Kant was held in such high regard gave prestige to incomprehensibility. And I think that's bad. That's really bad for philosophy. I mean, I try to take things like general relativity and say, look, I can explain this to you so you really understand it. I don't say, oh, it's mystical and you have, I mean,
Yeah. If I could use a colloquialism from the kids, it's not that deep, bro. Yeah, no. So I think there's something there, certainly. All right, so now I'm gonna again a little controversial, I guess, or provocative here, which is I want to talk about. So my learning of physics, of course, has been from reading your books, but then also books that are written a bit more to, let's call it, like pop physics or the general public. Books like The Order of Time by Carlo Rovelli or Time Reborn by Smolin. I love reading these books, but then my problem is, again, what they posit is something, at least for me as a layperson, it's rather bizarre. Like, for instance, um, Carlo Rovelli, my understanding is he kind of posits that like time is in not a fundamental reality of the world, that it's in some sort of local phenomena. And then Smolin, especially in Time Reborn, but even in this book, Trouble with Physics, kind of views understanding the laws of physics through almost like natural selection or like an evolutionary lens where like the laws of physics themselves evolve. And he even says, yeah, something like quantum mechanics, it's a subsystem of a larger system. So there are all these views. And I mean, I'm sure you're familiar with kind of what their philosophy of physics.
Mhm.
So again, a very broad general question, Professor. Like, yeah, what are your views on that kind of? I mean, these both they're physicists. They're not philosophers of physics, so like they know their physics well. But then there's like very radical kind of interpretations of physics.
Yeah.
What are your general views on that?
Well, look, first of all, as they would both admit, what they're trying to argue is highly speculative, right? They're not suggesting that regular physics experimentation and kind of regular inferences are leading to these claims they're making. Um, and when physicists, they're human beings, when they allow themselves to speculate, and no one's saying they shouldn't allow themselves to speculate, sometimes they kind of just take off all the constraints, they release all of the safety belts and just let themselves go. Okay, I mean that's kind of fun. Too wild speculation. Again, it's not to my taste. You can't prove it's wrong, but I'm more interested in why would you think it's right? Then there are logical problems, right? So if you say, gee, the laws of physics themselves evolve, well, for something like uh, Darwinian evolution to occur, which is the analog you're gesturing at, there have to be some fixed laws of physics for evolution to occur. If everything's just kind of randomly jumping around, if the laws themselves were randomly jumping around, animals couldn't evolve, right? Because to evolve, they have to the effects of their behavior have to be constant over time, right? Doing this if doing this helps you now, it better help you tomorrow and the next day and the next day. But if the laws themselves or the rules are changing rapidly, you can't even have evolution. So then you get into a meta problem. You say, well, if the laws themselves evolve, the evolution needs a set of
Yeah.
meta laws,
Yeah, and
right?
is
But
that a law?
now we're
It's
just going
sort of
around, right?
infinite. Yeah, yeah.
And it's like people have some weird views about time that then seem to there has to be a meta time. And you say, wait, now you're not getting anywhere, right? If you're happy to postulate meta time, then just postulate time. I mean, you're not making any progress with this. I think a lot of stuff about time in physics is just poorly argued. And part of the problem is, again, because the physics education has stopped being about what is the fundamental postulates of your theory and why do you believe them. Um, when physicists start to speculate, so they start saying, oh, well, what if it's like this? What if it's like that? But they don't have real good training in how do I make this plausible, or how do I motivate it, or how do I make this seem like a reasonable supposition? Maybe it's not true, but at least it ought to be reasonable. But I don't see much of that, right? Um, I personally have been arguing for a long time. There's no problem about time at all of the kind. People think time is this big problematic. It's one of the most unproblematic things there is. I mean, there are different temporal structures. Relativity suggests a different structure of time than Newton had, fine. But that there is a structure of time and it's just there and it's part of the job of physics to figure out what it is. And you know, that seems right. And that time has a direction and that things proceed from the past to the future and, you know, stuff like that. All of this, there's no reason not to believe it. Now, somebody can say, oh, maybe I can have a speculative theory where it's all very different. But sure, but now we're back to like, yeah, maybe we're plugged into the pods, you know, in the
Yeah,
matrix. I mean,
in
why
the
are you doing
Matrix.
right? What is your motivation for doing this rather than just trying to be clever or be provocative or, you know, or make a public audience go, wow, blow my mind, you know. You know, I mean, I don't, the books I wrote, the ones you mentioned, the philosophy of physics, space and time, the philosophy of physics, quantum theory, are meant for an audience that are not don't have a background in physics, namely a basically philosophical audience. So I'm not assuming a background. And I'm trying to explain this stuff as clearly and comprehensibly as I can. And I think to do that, you can't really make it a popular level book. There has to be a bit more, a few equations and a bit of fairly careful, nitpicky discussion, which doesn't sell, right? That's not the kind of thing that sells. What sells is, yeah, you know.
Yeah, yeah. I mean, I've got to admit, like, I've recently been teaching myself a lot of mathematics because of my master's and like the work I'm doing in computer science. But like, the limits of my technical knowledge in physics has been Tim Maudlin and David Albert. Like, this has been my where I've really pushed myself to. And I agree, like, Order of Time, I listened to that book as an audiobook. Like, it was a lovely, beautifully, he's very poetic. I love Carlo
Mhm.
Rovelli's the way he writes. But like, I couldn't do this as an audiobook. Impossible. You gotta
Yeah,
sit and you gotta work through it. Like the 8 experiments, there's no way I can
yeah,
listen to it as an audiobook
yeah,
because
yeah.
you gotta work through it. And you're right. Like, this is. I mean, I hope you don't get offended by this, but this book isn't selling as good as, I don't know,
I
Time Reborn or
cer-
Order of
I certainly
Time.
never expected it would, right? It wasn't
Yeah.
my intention to make it a popular book. As I said, I mean, my wife sometimes tells me you should write a popular book, and I always think about it and I think I don't think I could simultaneously do what needs to be done to make a book popular and satisfy my own conscience about not cutting corners, right? And not kind of glossing over things and just giving you kind of half good analogies. I mean, um, it's, this is kind of exacting work. And exacting stuff is not all that popular. I mean, some people look, some people, I mean, you probably, I don't know if you read Gödel, Escher, Bach,
Yes,
but
Offsetter,
okay.
yeah,
I
of
mean,
course,
that was
yeah.
kind of a brilliant book, very
I was going to ask you
entertaining,
about
and
that
he
book.
did sort of
Yeah.
get into Gödel's theorem in a pretty good way and explain some technical stuff, and also was very entertaining and very clever and fun. But I don't have the skill to do that.
Yeah, this one, yeah, yeah. I've ravished through it. Oh, you can't see that. Yeah, yeah.
Yeah.
I know, but like the thing though is, it's funny. Like now that I've actually spent a bit of time trying to grasp Gödel's theorem, I find that yeah, it was a very fun book to read, but this probably isn't the best book to read if you want to understand Gödel's theorem. There are,
Yeah.
like, for example, Ernest Nagel's Gödel's Proof is a much better book to understand Gödel's
Right.
theorem, I think.
And that's never going to sell as much as Gödel, Escher, Bach.
As Escher Bach, right? Yeah, this book really, in many ways, people went into AI research because of this book. So it's fascinating stuff. All right, great, Professor. Now I want to get back to again because you're arguing here, kind of. So let me just put it this way. I think two talks of yours that for me personally was like the impetus behind reaching out to you and kind of proposing this topic was one was a talk you gave, I think now probably this was in 2014 at Western University. It was called How Physics Meets Epistemology. It was a really great lecture. You've probably forgotten a lot of it. I mean, it's a long time ago. And then another
I
one
don't have any
was
specific memory.
yeah, yeah, it was a great talk. It's on YouTube, and it's got a couple of thousand views. And the other one was this was, I think, 1 or 2 years ago. It was another interview you did with, I believe it was the European Institute of Management, and it was called "What Makes a Good and Clear Theory of the World." So, in both of these talks, really, what you were trying to delineate was between, what entails a good theory of physics, and what is a proper standard of evidence. But then also, in both of these, you kind of did intimate at this point here with what I would call like the hegemony of physics. And just, if I may, just for a moment here, like what you were trying to say was, okay, look, a physicist for some reason can't say, "Oh, that's beyond my domain." Like a
Right.
biologist or a chemist could say, "Yeah, I'll explain things to this level, and then after that, that's beyond my domain."
Mhm.
So I'm not even sure how to ask this question, but do you mind kind of expanding on that point? Like, what is it about physics in particular that has this almost uh epistemological hegemony, or it doesn't like, it's not like any other science, so to speak.
Yeah.
It has something distinct to it.
Right. I mean, I think it does have something distinct to it that is important for its methodology. Um, I don't think the word hegemony is the right word. It programmatically has a universality, and for reasons that are very easy to explain. So, think of a biologist. A population biologist is, I don't know, looking at a population of orangutans and trying to figure out, why it fluctuates in certain ways, given the weather and the predators, or, you can imagine something like that. Um, and maybe they even come up with a kind of mathematical model and they say, I think next year the population is going to increase. Yes. And then the next year comes around, and unfortunately, an asteroid falls onto the forest and kills all the orangutans. Um, now, your prediction about the population really went bad there, but as a biologist, you're within your rights to say that wasn't, that's not my department, said Werner von Braun, right? I was not trying to predict non-biological interventions into my biological system, right? You can't fault my biological theory because of that, because it's a kind of astronomical event that's not within the scope of what I was trying to do. However, the point is, every biological system, every orangutan is also a physical system. Every asteroid is also a physical system. Every star is also a physical system. Everything, right? Every economic system is also a physical system. So all of those, in principle, the physicist better get right just using the concepts of physics, right? They ought to be able to treat every system as a physical system, and it is incumbent upon physics never to take this out, right? I mean, sort of Descartes would. He'd say, "Well, yeah, using my physics, I can explain all the stuff going on in your body and so on, and up into your head, and I get to the pineal gland, and then whoops, all of a
Yeah.
sudden, this funny swerve happens. That's because I've got this non-material, immaterial soul that did something, and so I'm off the hook there. My physics doesn't have to explain that, but we don't think that's good anymore. We think that physics is, aspires to this absolute universality, because every object of empirical science, whatever else it is a physical object, and therefore falls under the domain of physics. Now, that's not to say, and I want to be very clear about this, that every other science reduces to physics. It doesn't. Physics tries to explain things using the proprietary concepts of physics, and biology uses different concepts, and computer science uses different concepts, and meteorology uses different concepts, and so on. And often those other sciences and their conceptual apparatus are more revealing and give us more insight into what's going on than a purely physical analysis could do. So it's not that somehow the other sciences are below physics in some sense of understanding or what they're providing. Not at all. That's a mistake. And I think people often make that mistake, that they think, all right, there's this ontological claim, which I think is true. Every subject of every empirical science is also a physical thing, subject to the laws of physics. That's true. It does not follow that every other science reduces to physics. That's untrue.
Yeah, I mean, also like for me, again, I go back to your kind of like, common sense intuitively. For example, if you take McDonald's and if you think of the system of McDonald's, um, well, yeah, of course, it's a physical system, but when I think of, let's say, McDonald's as a phenomena, it's not just, I don't think of it just as like atoms and quarks and like in the
Right.
language of physics as like a system. I mean, even at the level of like, yeah, the fast food, the burgers come
Yeah.
together and there's like all of that, it seems like something emerges beyond just the pure, let's call it brute physical phenomena.
Yeah.
And I mean, you said this too. Like, for example, and correct me if I'm wrong, Professor. You would say you're a mathematical Platonist, but even when it comes to the realm of ethics, you are a Platonist. And then you also make the argument. Here's where I think this like whole with like quantum physics woo-woo stuff goes wrong, where people reach and say, oh, because quantum theory tells us is therefore we should like love each other and be human. But then the point you make is, well, what if quantum theory is false? Does that mean we should become all murdering sociopaths?
Yeah. Right.
So there is it's a subtle point there. So okay, again now this you might say this is like what people do just kind of because it's fun and speculative. But like of course, as you mentioned, Gunnar Shabak, very fun book to read. But then the other person I can think of here is because you mentioned Descartes, is like Roger Penrose with like
Mhm.
microtubules in the brain, and there's like a quantum collapse, and that's how consciousness comes into being. So when you see like people who have a solid background in physics, certainly a lot more than what I would ever have, doing this kind of work, generally, like, I mean, you don't do it yourself as a scholar, as an academic, but generally, how do you think the general public should approach when you see like all these physicists talk about this rather make this rather speculative claims, like because we're talking epistemology here,
Yeah.
what kind of, let's say, guardrails we should be putting in when we do accept these claims about reality?
So look, I don't think one can helpfully generalize here, um, because you're talking about very complex psychologies. So take Penrose. Um, Penrose has this big book called The Road to Reality, and it's a very technical book. It even has problem sets in it. There's some explanations of math, for example, of just pure math, which are brilliant. I mean, you will learn a tremendous amount from studying some chapters in that book. Um, but Penrose himself got misled by Gödel's proof. I mean, that this comes up in, The Emperor's New Mind and so on. He somehow thought he could parlay Gödel's theorem into a proof that physics can't be computable. Now, I have to say, I think every expert I know on Gödel's theorem says that's wrong, and they're right. I mean, I'm not a deep expert. I know enough. I mean, I've taught Gödel's. I know what it says, and I know this does not follow from it at all. Um, Now, why does Penrose keep doing that? And then that gets him to non-computable physics, and then the stuff about microtubules and collapses. Okay, it's all kind of connected in his mind. Why didn't he pay attention when he published that book, and essentially every expert in the field said, you're making a mistake here? Well, he's kind of lives in his own mind. I mean, he does. It's worked out well for him. I mean, I mean, he's done a lot of interesting things, and that, it's a way to make progress, in a way to shut out everything and just pursue your ideas. But there's a certain point where it can also lead you down a bad path, because a lot of people who are noticing you're making a mistake keep yelling at you, that's not right, and you just ignore them, right? It's very hard to know, when is it the one and when is it the other? When is it somebody with a deep, brilliant idea that nobody else appreciates and has to push on? And when is it somebody who's gone off the rails and is ignoring a bunch of other people who've noticed they've gone off the rails? And you can't generalize. Um, so I don't think it would be useful to give a general advice. How should you react to physicists? Some of them are really bad. I mean, look, some of them, I'm not going to name names here. Some of them are just publicity hounds, right? I mean, some of them are just trying to sell books. Some of them just have gotten to a point where they're trying to say stuff that'll make a lay audience sit up and go, wow, because they like that. Some of them have interesting ideas that are kind of not quite fully baked and they're pushing them. Some of them, they're really less than half baked and they're pushing them. Sometimes they're telling you things you're not expecting and they're really deeply insightful. There's just not a rule here. And unfortunately, it would be great if there were. It would be great if you could just open up one of these books and have some algorithmic test of how seriously should I take this. But there isn't, right? All you can do is try and follow as much as you can. Hopefully what they're saying is clear enough, and then trying to think independently about it and listen to other people who are criticizing it and come to the best judgment you can. I just can't give you better advice than that. Certainly, one thing sure is that having done absolutely great work in physics in some area is no guarantee that what people will say on other topics, certainly not on topics outside physics, but even on topics outside their specialty in physics, is even, serious. I mean, it can be way off base. That happens. That's just, human psychology.
Yeah. I mean, just on the note of like being provocative here, I think here's a good example of, in our like neoliberal society, where when you see all these like tech people, like, rich tech people make, have like these commentaries on sociology and economics and philosophy and politics, and it's like, it's people think, oh, just because they've made a lot of money in some
Yeah.
tech company, they're these universal geniuses who understand all of reality. But
The
that's
big, the
just,
big problem is that they believe that, right? I
I mean,
mean,
yeah, in
that's
fact,
why
I
we're
would
in such
probably
a
say that's the
mess.
biggest
They
problem.
have
Yeah,
this unbelievable
correct.
self-confidence because they're
Hubris, yeah.
rich,
Yeah. I mean,
that
that's
they
even
must be
worse than
brilliant.
what we're discussing. Yeah.
And I must say, anybody paying attention can very well see that being rich doesn't mean you're brilliant.
Oh, yeah. And I think we're seeing it unfold, in fact, in
Yes.
the worst possible way right now in our society. That's for sure, Professor.
And let me make just a short, because it's something I mean, here in the United States, of course, people keep throwing around the term oligarchy, right? That or
Mm,
authoritarian or oligarchy or so on. The right word is plutocracy. I don't know why people aren't using it. I mean, there's this weird idea, give the rich, take the rich people and put them in charge of everything. And that is just absolutely insane. It's
dystopian. Yeah.
and we're seeing it. And
Yeah.
it's just, oh, if they're rich, they must be smart. Nope.
Yeah.
Nope. Not at all.
Yeah. Yeah. I mean, look, as cliche as this sounds, you just gotta have critical thinking. I mean,
Yeah.
because the thing is, Professor, like, in a way, we all, like, for example, you're an expert, and I do go to you to understand things about physics. So someone would say, oh, you shouldn't blindly listen to Professor Maudlin and just like read his books and accept what he's saying. But I mean, a part of, I think, critical thinking is knowing what your limits are. It's knowing, okay, I mean, you ask me about computer science, sure, I'll know a thing or two. But maybe when it comes to quantum theory, I probably should go to the experts and listen to them. And if I want to pursue that more, then sure, keep it. And one thing, here's where I'm not a fan of this notion of universal genius. These like people like who are like suddenly they're born being super smart, like innately intelligent. I always look at a person's track record in this sense, like, have they been at this field for 30, 40 years, putting away the hours, writing books, researching, getting into debates? There's something where I respect a person like that more, and I probably listen to what they're saying over like some, I don't know, some person that like appears out of nowhere and has this radical theory of reality.
Yeah, I mean, let me just say,
Yeah.
look, people should be giving arguments. They should be giving evidence. They should be giving data. I don't care what your background is or whatever. You make an extraordinary claim. As they say, extraordinary claims require extraordinary evidence. Just making a wild claim is nothing. You have to motivate it. Now, I certainly try in my books as hard as I can to motivate and explain and go through arguments in a way that people can check themselves. I mean, Feynman said once in a very nice thing, although this is a somewhat higher level than popular exposition. He said, if you can't explain something to the freshman class at Caltech, you don't really understand it. You yourself do not understand it, right? That if you really understand something, usually you can boil it down and present it in a way that a reasonably intelligent person with at least a bit of background can follow what you're saying and actually make a judgment, make a firsthand judgment. Yes, what you're saying follows. Yes, this makes sense. Or no, it doesn't. The best thing to do, again, of course, we wish there was some easy way to identify the real experts from the charlatans and the self-deluded people and the crackpots, right? I mean, it would be great
But there
if,
isn't.
if it was, tattooed on people's heads, but it isn't. One thing you can do is if you know something about one subject and you're pretty confident and they make claims about that subject, pay attention and see, are they getting it right or are they getting it wrong? Right? Because sometimes you are in a position to say, well, at least they were reliable here or they were unreliable here. Right? I don't know what more you can do. And maybe you can find people who are like, seem to be reliable guides to who the reliable guides are. Right?
Yeah, correct. I mean,
So
you gotta in a way you gotta defer to the experts, but also knowing which experts to defer to itself is
yeah,
a it takes a sense of critical
right.
thinking. Yeah, yeah. Excellent. Thank you for humoring me with that, Professor. All right, so I guess in the interest of time, I probably have two more questions, if it's okay with me, for like 5, 10 more minutes. I know it's quite late for you. You've had your coffee, but back to this conversation you were having on with this in the European Institute of Management with that gentleman. This was again a while back, so you've probably forgotten. But you guys did touch on a very interesting point, which I want you to elaborate a bit more because you couldn't really explore it, flesh it out in that conversation. You're quite critical of this notion of interpretations of quantum mechanics. And I mean, I feel like you don't even like that term. You just say there are three things. There's the mathematical representation, there's a theory, and there's an interpretation. And you kind of said that sometimes people they call it theory and interpretation, and they kind of mess it up, they obfuscate.
Mhm.
So if you could outline, yeah, what are the three things? So there's a mathematical representation, a theory, and an interpretation. And how should we, again, as lay people, think of these things when it comes to
Well,
specifically physics?
as you say, I actually don't like the word interpretation in discussing foundations of physics. I don't think I ever tried to define it. I just think it's a word we shouldn't use. Um,
Mm-mm.
for me, a theory, a physical theory, it may not be completely precise and absolutely worked out, but you better be able to say, okay, according to this theory, A, what fundamentally exists, right? What is there? Like, are there particles? Are there fields? Are there, I mean, I could give you a bunch of options, or maybe it's something you've never thought of, but now you have to tell me about it. That's fine. So, what is the fundamental ontology? That is, what is it your theory postulates to exist? And second, how does it behave? What does it do? Right? Normally, you specify that
Dynamics.
with some equations, some dynamics. Okay. Um, Now, the problem is that what is taught as quantum theory, if you got a book, a standard physics text called Quantum Mechanics or Quantum Theory, and you read it carefully, and you said, yeah, but what is really being postulated to exist here? You wouldn't find an answer in that book. They just don't address that question. What they give you is what I call a predictive recipe. They say, okay, if you want to make certain kinds of predictions, do this, calculate this, run this through this mathematical device, and what spits out the other end are some usually statistical predictions for the outcome of your experiment. That just isn't a theory, because it doesn't answer these questions. This was the attitude this is often associated with an attitude called instrumentalism. And the example that I often use, because it's true historically, you remember when Copernicus was writing his book, attacking Ptolemy, right, attacking the Earth-centered theory and putting a sun-centered theory where the Earth is rotating and orbiting the sun. Copernicus knew that was a dangerous theory because it seemed to contradict some stuff said in the Bible if you take it literally, right? When Joshua, the sun stopped moving, right, in the Battle of Jericho. Well, then the sun must be moving, right, and not the Earth rotating. Otherwise, the Bible would have said suddenly the Earth stopped rotating. Okay, so Copernicus knew this was kind of a dangerous doctrine. And he didn't actually publish the book. I mean, it was published kind of on his deathbed. And when it was published, there was a preface to it which you would have thought was written by Copernicus, because they didn't tell you, but it wasn't. It was written by this guy, Osiander. And in it, Osiander was trying to protect Copernicus. And he said, look, don't take seriously as literally true what is said here, that the Earth is rotating and orbiting the sun. All that's being said here is that if you pretend that this is true, you can make some good predictions, right? That if you want to know where to look to find Mars in 3 months, you can use this to make those predictions, and they'll be good predictions. That's instrumentalism, right? Instrumentalism says, I'm not attempting to give you an accurate account of what's really going on. I'm just giving you a kind of calculational tool to predict what'll happen. That's what you have in a standard quantum mechanics text. So it isn't a theory. Now, when people then talk about interpretations of quantum theory, what they really mean are theories. They're different theories. They're mutually contradictory theories that try to go much further than just give you this predictive recipe. They say, maybe this is what's going on. Or maybe that's what's going on, right? Does the wave function collapse? Does it not collapse? Are there particles? Do the particles move? Do they not move? What's an electron doing in a hydrogen atom? Is it orbiting? Is it popping in and out of existence? All these kinds of things. This is what a theory has to answer. And what people call, quote, interpretations of quantum mechanics, they're speaking as if quantum mechanics is a theory, and then you're adding to the theory this other level of something you call an interpretation. That's not the right story. The story is what you call quantum mechanics isn't a theory, it's a predictive algorithm. And what you're trying to find are clearly articulated theories that would give you those predictions, or at least, nearly those predictions. That's what's really going on. And the language is systematically misleading. And as I often say, the reason why it's worrisome is that a physicist using that language can say, well, look, I've got quantum theory. What do I need an interpretation for? Who's doing this interpreting stuff? Oh, those are all philosophers. That's not physics. That's some other discipline. And they say that because they falsely believe that what they've got in their physics books is a theory when it isn't. And Bell complains about this, and Einstein complains about this, and Schrodinger complains about this. I mean, the physicists complain about it, that what was being offered as quantum wasn't even a clearly articulated account of the world. And that's what physics should be aiming at. I think that's absolutely correct.
Yeah, that's true. I mean, also here's where Bell introduces you've spoken about this quite extensively. Notion of like behables, like forget
Yeah.
about observables. Let's talk of ontology, behables.
Yeah.
And what's interesting is like for a person who has just a marginal knowledge of philosophy, totally get what ontology is. Like you understand, like, oh yeah, of course, you want to speak about what's there, but then it's surprising that for like let's just say a physics student, you need to even use this term behables to even like you need to invent a word to describe what's really there. Excellent. All right, Professor. So, on the note, this is my last question. I think I mentioned to you when I initially reached out. Uh, Barry Lower and Robinson Erhard were discussing the philosophy of science, and then they kind of said as like a cheeky comment, they were like, "Oh, Tim Maudlin he's a like he's got an amazing way of arguing and bringing forward arguments." And then Robinson said, "Oh, he could beat me in what I had for breakfast. He could convince me otherwise." But
Barry
of
said
course, they
that.
were. Oh, the Barry, yeah. But of
Barry
course, they
said that,
weren't.
and I wouldn't complain to Barry after he said it. I came down hard on him. I really hated that he said that. I thought that was really a bad thing to say. And he kind of admitted once I pointed it out.
Yeah, but I think they weren't calling you like a sophist. They were saying that that's like you rigorously argue certain points, and here's where I kind of wanna. I was like, yeah, okay. I mean, why is it that when I listen to someone like Tim Maudlin, I had the sense of like, it's like the argument had like a weight to it, but then I listen to someone like, and forgive me if I'm gonna rehash all arguments and ruffle any feathers, someone like Bernardo Kastrup, who is an
Hmm.
idealist. I'm always like left with, yeah, I mean, it's very alluring, but I don't know. That's like, it's quite a reach to say that all that exists in reality is mind. And, we already had this discussion.
Hmm.
So if you were talking here, not even to physics students, like anyone who's doing any kind of thinking, academic work, philosophy, it could even be in I don't know, sociology for God's sake, or economics.
Hmm.
How do you think, how do you think a person should approach when making arguments when it comes to whatever your field is?
Sure.
Generally, let me just say, what's your like modus operandi, so to speak?
Look, I actually I think this is kind of simple. There's a difference between reasoning and rationalization. And the difference is very simple. When you're reasoning, you start with some premises that you think are really worthy of belief, and you can, say why they're worthy of belief. And then you're trying to figure out what follows from them, right? And you're working your way from this very solid foundation, maybe to very surprising conclusions, right? You try to be careful and so on. So anyway, that's the direction of reasoning. And you reach certain conclusions, right? But once you reach those conclusions, if someone says, "Why do you believe that?" then you just repeat the process by which you arrive there, right? Rationalization is where you've fixed a conclusion that you just like or whatever. You just attach yourself to the conclusion.
Yeah.
And then you say, "I'm going to try and find some arguments for this," right?
And
It's
like
back,
retroactively, yeah,
you
yeah,
know.
yeah.
I'm and this is the same thing when we, this nonsense when people say, "Oh, go do your own research," right? What do they mean? They mean you have a fixed belief. Now go on the web and troll it until you find somebody who
When it
says
comes
what
to
you already
vaccines,
believe,
yeah,
and then
for
say, "Oh, that's
instance,
the
yeah,
expert." I mean, that's
yeah.
rationalization. That's not reasoning. And rationalization doesn't produce convincing arguments because they're just making whatever moves or whatever to get them to where they want to go rather than following the logic where the logic takes you, right? They're hoking up bad arguments because they know the conclusion they want to arrive at. And the problem is, on the surface, these look very similar, but at the base, they're completely different. And look at
Correct, yeah.
politics, for God's sake. I mean, politics is all rationalization and no reasoning,
Yeah,
right?
and the truth is, like, there actually are very good economists, political philosophers, political scientists who've done the work, and they've got really legitimate theories of our social existence. But nonetheless, because of this point you make, I mean, a case in point would be vaccines, right? I mean,
Mhm.
I'll do my own research on vaccine science or like what on the toilet while you're on your phone. It's bizarre and it's unfortunate. And here's where I think I still, as cliche as this sounds, again, I do defend this like enlightenment, reason, critical thinking, the stuff that we were supposed to be taught at universities, because in our culture, as we sort of touched on, we are moving towards this like almost like this anti-intellectual, where it's like like anything goes kind of reality. And frankly, I think it's leaving us in some kind of a mess. And here's where I think all of these, again, these fundamental questions about like epistemology or like even pedagogy do matter. But yeah.
I mean, look, you're
Professor,
absolutely. I mean, take vaccines.
yeah,
I mean, the track record. We eliminated smallpox. Why?
yeah,
Because
and
we.
measles, yeah,
I mean, that's what vaccines were originally developed to prevent smallpox, right? And literally, we've eliminated smallpox. Terrible, terrible thing. Oh, essentially eliminated polio. Terrible, terrible thing, right? The track record of vaccines for improving humanity is so massive and so undisputable that anybody who can now say, oh, I don't know about vaccines, right? I mean, this is insane. But they do. And then they get other people who pile on and be, oh, no,
yeah,
they're just, it's the pharma company, blah, 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 right? I mean, it's terrible.
yeah.
And it
For
will lead us
me,
to disaster, and it
yeah,
will lead us to disaster. It
and
absolutely
for
will. It is.
me, for me, the ethical quandary, even the moral quandary with vaccines, there's no quandary. It's just an abomination with vaccines. Is like, okay, we can discuss the foundations of physics. I'm not saying that that stuff isn't has no material impact on our lives, but when it comes to like medicine,
No, that, yeah.
parents,
Look,
kids, children not getting vaccinated. I mean, I see in Texas, there's like
yeah.
I think there's measles
Measles,
back home,
measles
whatever.
is coming. We almost had measles wiped out in this country. Then people decided, oh, I don't want to
It's
vaccinate my
bizarre.
kids. And gee, what a surprise, we're getting measles
Yeah.
again.
And we've got the same problem now here in Australia. There's like a huge anti-vax movement, and now that we've touched on this, Professor, I'm sure. So I apologize. You're probably going to get a couple of emails. I mean, I hope not, but they come out of nowhere. No, thank you for humoring me with these questions. I mean, I know that normally you stick to the physics and that stuff, but I thought it'd be fun to kind of discuss more of these
Sure.
philosophical questions. But Professor, as I said, I've been a student of yours for years now, and it's been a privilege. Thank you so much for your time.
Okay. It's been fun. It's been an enjoyable
Yeah,
conversation. So
thank you so
thanks for
much.
having me.
Cheers.